In section 9.5, we're going to do the quadratic formula. So what are we going to learn? Well, obviously, we are going to be learning how to solve equations using quadratic formula, how to interpret the discriminant, and how to choose efficient methods for solving quadratic equations. So using the quadratic formula, by completing the square for quadratic formula, you can develop a formula that gives the solutions of any quadratic equation in standard form. This is called the quadratic formula. Here it is. Negative b, now x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now a cannot be 0 because that would give us a number divided by 0. And in this case, b squared minus 4ac has to be greater than or equal to 0. If it's going to be negative, you're going to get the square root of a negative, which gives you imaginary numbers, which you learn next year, actually, no, in 2 years, as freshmen in Algebra 2. So example 1, quadratic formula. The only real thing that's going to be difficult is putting everything equal to 0. In standard form equal to 0. So, we have everything here. A is 2, B is negative 5, and 3 is C. So all we do is we take our formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. I just plug everything in. Negative b, well b is negative 5, so it would be 5 plus or minus the square root of b squared, make sure negative 5 is in parentheses, minus 4 times a, or multiplied by a, multiplied by c, divided by 2 multiplied by a. All I do now is basic simplifying. That would give me 25 minus 8 times 3 is 24, all divided by 4. That gives me 5 plus or minus, well that's the square root of 1. The square root of 1 is just 1, divided by 4. That means I have two answers. 5 plus 1 is 6. 6 divided by 4 is 3/2. So x equals 3/2, and 5 minus 1 is 4. 4 divided by 4 is 1. If you substituted both of those back in, you would make the equation true. And so our answer is 3/2 and 1. Now you may say to yourself, Mr. Humphreys, why can't I factor this? Up here, way up here, why can't I factor that? And get x minus 1 and 2x minus 3 and solve that? You can. This is just yet another tool, because sometimes you can't factor. And so quadratic formula works for everything. Example number 2. The number y of Northern Rocky Mountain wolf breeding pairs x since 1990 can be modeled by the function you see there. When were there about 35 breeding pairs? Step 1, we plug in our value. 35 is y, so we're going to get 35 equals 2/10 x squared plus 1 8/10 x minus 3. I have to get everything equal to 0. So I subtract 35, that gives me minus 38. So now I just plug everything in to quadratic formula. Negative b plus or minus the square root of b squared minus 4 multiplied by a multiplied by c divided by 2 times a. If I simplify all of this, I would get negative 1.8 plus or minus the square root of 33.64 divided by 4/10. That gives me 1.8, negative 1.8, plus or minus 5.8 divided by 0.4. If I simplify that, 5.8 minus 1.8 gives me 4, divided by 0.4 gives me my first answer of 10. And if I did the other way, I would get negative 19. Well, we can ignore the fact of what? Of negative 19. Because negative 19 represents the year 1971, which is not in the given time period. So, years since 1990 would be 10 years. So, because x represents the number of years since 1990, and x is greater than or equal to 0, there were 35 breeding pairs 10 years after 1990, which is in the year 2000. Which leads into our next problem, interpreting the discriminant. The discriminant is what is underneath the square root. That is the discriminant, b squared minus 4ac. Because the discriminant is under the radical symbol, you can use the value of the discriminant to determine the number of real solutions of a quadratic equation. Make note, real solutions. Because we can get imaginary solutions, which we're not talking about. And the number of x-intercepts of the graph and the related function. So here's how it works. Now make note right here, the solutions of a quadratic equation may be real numbers or imaginary numbers. You will study imaginary numbers in a future course. Let's put this back. So, think about it. If you took the square root of a positive number, that gives you a plus and minus value of that. So you're going to get 2 real solutions and 2 intercepts. If you take a square root that is 0, the square root of 0 is just 0. So you're going to end up with only 1 real solution, which is 1 x-intercept. If you get a value that is negative, when you take the square root of a negative, it won't work. You won't get any real solutions. So you'd have no real solutions and no x-intercepts. So part A of example 3, tell me the real solutions. Give me the real solutions, if we have any. So, all I do is b squared minus 4ac. I just plug it in. So, that gives me, let's see, b squared minus 4ac. That gives me 64 plus 12, which gives me 76. It's positive. I have 2 real solutions. So, what does that tell me? I have 2 real solutions, which means my graph would cross it how many times? Twice. So the next one we're going to determine is 9x squared plus 1 equals 6x. Step 1, we have to get it in standard form. 9x squared minus 6x plus 1. I plug it in. B squared minus 4ac. That gives me 36 minus 36, which is 0. This gives me 1 real solution, which means you'd have 1 x-intercept. There's a difference between finding the x-intercepts and finding how many solutions there are. So in this problem, how many solutions are there? So b squared minus 4ac. That is 9 minus 72. That gives me negative 63. This has no real solutions. So here's a review of everything you've done. You have solved by factoring. Factoring is straightforward when you can factor easily. However, some equations are not factorable. You can solve by graphing, but it may not give exact solutions. And you can use your graphing calculator, so that makes that easy. Square roots only works when you have x squared equals something. It only works for some things. Completing the square is best used when you only have an a or b value. However, it's hard sometimes. Quadratic formula, this is probably the best. It gives exact solutions and it is used for everything. It works for everything. The real only disadvantage is it takes a little bit of time to do the calculations. So here we go. We have 3 examples. 3 examples. Solve the equation by any method you want. What I am going to show you is how I would do it. It's not how you have to do it. So in A, I look at this and say, well, it kind of looks like completing the square. So that's what I'm going to do. I have students that want to get everything equal to 0 and use quadratic equation every time. Or they try to factor first. That's okay. So I'm going to complete the square. X squared minus 10x, half of negative 10 squared is plus 25. I have to add 25 on the right side, which will give me 26. I then get x minus 5 squared equals 26. I take the square root, which is x minus 5 equals plus or minus 26. I add 5. Actually, that would be the square root of 26. I add 5, and that gives me 5 plus or minus the square root of 26. There's my answer. You wouldn't have been able to factor it. So B, I could factor this, and you could. But to me, it's not an easy factoring problem. Well, it actually is, but you may look at this and say, I'm just going to use standard form. I'm going to use completing this quadratic formula. Negative b plus or minus b squared, that'd be 169, minus 4 multiplied by 2 and negative 24, all divided by 2a. That gives me 13 plus or minus the square root of 361 divided by 4. That gives me 13 plus or minus 19 divided by 4. 13 plus 19 divided by 4 is 8. And 13 minus 19 divided by 4 gives me negative 3/2. You could have also factored that. This one I'll try to factor. X plus, 4 and 3 would not work, 6 and 2 would. So I get x equals negative 6 and x equals negative 2. As you can see, any of them would work. You could have used quadratic formula here, you could have factored here. It doesn't matter.